All right, trigonometry students here. Here's a homework that is promised, or solutions to the homework from 5.2 and 5.3. And these are the homework problems here, just so you know have it. So let's go for it here. These are the questions from a class. So 5.2, number 5, it says find the sine of 7 pi over 12. So before you do that, you have to figure out what two angles will add or subtract to give you 7 pi over 12. The angles that we do know already, if you kind of start doing the list here, pi over 6, which is kind of the equivalent of 30 degrees, pi over 4, which is 45 degrees. Again, not dealing with the degrees, we want to deal with them in radian measurement here. So the other radian measurement we know is pi over 3, and then the other one is pi over 2. Okay, based upon those four items, the question is, can we come up with something that's going to add up to 7 pi over 12? The only issue is you have a 12 as a denominator, and these don't have 12 as a denominator. So what we're going to do is we're going to make all of them to be a denominator of 12. So the question is, what do you multiply 6 to give you a 12? And then so on and so forth. So 6 times 2 gives you a 12, therefore 2 times pi gives you 2 pi. Then it's 4 times 3 gives you 12, therefore 3 times pi gives you 3 pi, and so on and so forth. So pretty much we're just putting all of them as to a denominator of 12. There it is. And the last one, multiply by 6, and there it is. So, let me back up just a little bit here. So which one of those is going to add up to 7 pi over 12? And notice that the smallest one we have is 2 pi over 12. So 2 pi, 6 pi is going to be 8 pi. That's not going to be too big. Therefore, we're going to add the 3 and the 4 to make the 7. So 3 pi plus 4 pi would make the 7 pi over 12. And again, think about which angles are those. Those adds a pi over 4 plus a pi over 3. That's the angles that we want. So now I think we're ready to do our problem. So this one I'm going to make it is to be an addition of pi over 4 plus a pi over 3. Alright, you can pause the video if I'm going a little too fast here. Alright, with that we're going to use our summation rule for sine. The sum rule for sine means sum of the first angle times cosine of the second angle plus cosine of the first angle this time, and then multiplied by the sine of the second angle. So let's go for it here. So sine of pi over 4. Let me divide that page up so it looks a little better visually. Sine of pi over 4 is root 2 over 2. Cosine of pi over 3 makes a 1 over 2, which is 1/2, plus sine. Cosine pi over 4 is root 2 over 2, and then sine of pi over 3, that would make a root 3 over 2. So then multiplying those things together, let's see, on the left side, root 2 times 1 is still going to be root 2. 2 times 2 is 4. Going over here, root 2 times a root 3. So square root of 2 times square root of 3 makes a square root of 6. 2 times 2 is 4. So notice it's the same denominator of 4. So our answer should look like this. All right. A few things to mention here. And so let me look at the back of the book to see what answer they have. And okay, that's what I thought. Okay, so real quick here. You know that you can interchange addition. So here, pi over 4 plus pi over 3. It could be that you chose pi over 3 first and then pi over 4. So if you did that, then your answer would have came up with root 6 plus root 2 over 4. Those two mean the same thing, right? Because when you add two things together, you're still going to get the same thing. So be mindful if your answer is slightly different than the back of the book, but it really has the same value, you're fine. The only one that you got to be careful for is subtraction. So something like this. Root 2 minus root 6 over 4 is not going to be the same thing as root 6 minus root 2 over 4. Those are not the same. But addition, yes, they will be the same. Okay, so this answer, let's go with it here. So this answer is correct. If you got that answer somehow, you did good. And this answer is correct. So any one of those two answers would be just fine. The second one is what's in the back of the book. But both of them are just fine. Next one here. This is 5.3, number 13, it says cosecant t is equal to root 5 with t in quadrant 2. Find cosine of 2t. Okay, so let's go with it here. So first things first, remember that cosine, the double angle formula for cosine, has 3 different equations for it. So the question is, which one do you want to use? Depends on what information we have. And so there's the first one, cosine squared t minus sine squared t. The second one is 2 cosine squared t minus 1. And the last one, 1 minus 2 sine squared t. Okay, here it is. Which one do you want to use? Depends on what information you have. All right, so now let's deal with that piece right here. So cosecant t is equal to root 5. What we're going to do is we're going to take the reciprocal. So the reciprocal of cosecant. So notice it's going to be 1 over cosecant. And notice the other side is going to be 1 over root 5. And then we're going to take the reciprocal, or the trigonometric equation that is equivalent to 1 over cosecant t, which is sine. Sine t is equal to 1 over root 5. Okay, so notice what we technically have is we have sine t, and so the one I want to use is the third equation, because that's the equation that just needs sine in order to do the problem. All right, as mentioned in class, we normally don't do the first one because you need 2 pieces of information to plug in. Normally we use the second or third option. Second, if you know what cosine is. Third option, if you know what sine is. In this case, it lends itself really quick to this. Okay, once you do that, you can just plug it in. But I do want to show you another way, real quick here, to do this problem. If you went back all the way to the unit circle and you said to yourself, you know what, I know this angle, it's cosecant t is equal to root 5, or sine of t is 1 over root 5. You just have to make sure that you're in quadrant 2. There's my little dot. And we say to ourselves, okay, so that's 1. Sorry, it's actually not on the unit circle, but we still have the relationship of x, y, and r. R value is root 5. Okay, so it looks like we're missing the x. But notice that I've drawn the angle measurement in quadrant 2. That's important, or else you're going to get it wrong. Okay, if that's the case, notice I have everything else except for this x. I know what the y value is, and I know what the r value is. The reason for it, because sine is defined as y over r, or the y value divided by the r value. All right, so let's go with it here. So I think what we do is we do this. Oh, this should, x squared should have an x squared next to it here. So this is, we have x. Let me write that in. I'm going to write that in a little later here, just a second here, right there. So x squared plus y squared is equal to root 5 squared. And if we square all those terms, we're going to have x squared. Sorry for that, we should have had that in there. So I have x squared is equal to 5. I'm sorry, x squared is equal to 4. Take a square root of both sides, gets you plus or minus 2. Now the question is, which 2 do you want to use? Since we're in quadrant 2, we can write it as a negative 2 in here. Okay, notice if you go back to the unit circle, then you could use any one of these 3 equations. Right? I just want to show you that. You can always go back to, I'm sorry, not the unit circle. You can always go back to the relationship of x, y, and r. Alright, with that said, I don't want to go this way. Right? This is an option. This is an option that I think some students usually use because we are so familiar with going back to a graph form. But I'm going to go back over here. So we know sine t is equal to that. So what I'm going to do, okay. There's my cosine t if we ever need a cosine t. So once you get cosine t, you can use the second equation. Or you can use this first equation, plug in what you know for sine, plug in what you know for cosine. Any one of those is still going to give you the exact same answer. My preference, we just use what you began with. If you know what sine of t is, let's use the bottom equation. Let's put it all together. So 1 minus 2 times 1 over root 5 being squared. And we get to square that out. So 1 times 1 is 1. Square root of 5 times square root of 5 is 1/5 now. So the 2 multiplies the 1 in the front. need common denominators now here. So that 1 is going to change into a 5 over 5. And we subtract 2 from 5, and voila, we get an answer of 5/3. And let me just check the back of the book. That is exactly true. We got what we need there. Okay, next one. All right, now we come to the next problem. This is a proof problem, 5.3. All right, it's sine squared theta on one side, 1 minus cosine 2 theta over 2. So I'm thinking about this here, again, thinking with the end in mind on these. I need a sine on the left side, and I have 3 different options for cosine 2 theta, right? There's first formula, second formula, or third. Well, knowing that I need sine at the end of it all, I'm going to use a third formula for cosine 2 theta. So I'm going to start simplifying the right-hand side completely. So 1 minus, and here it is. This is formula number, or form 3. And that should be a 2. That should be a 2 there on the bottom of in the denominator. All right, with that case, let's see what I got here. This is 1 minus, the negative goes in. Negative multiplies into the 1. The negative also multiplies into the other, which makes it up 2. So it distributes. The negative got distributed. And I see what's going to happen now here. So 1 minus 1 is 0. I'm left with 2 sine squared theta on top divided by 2. Those 2's now will go away. And I'm left with what I wanted it to be equal to. So sine squared theta on the right matches the sine squared theta on the left. And I have myself a QED right there. Next problem. This one just had a little bit of a trouble on it, but I was able to solve it eventually here. So I need sine 3 theta. Ooh, a triple. Okay, hold on. This is triple of an angle. That's where kind of this fits in. Maybe makes it a little more difficult here. We've never seen 3 theta before. We know we can work with theta. We know we can work with 2 theta. But 3 theta, how does that work out? And eventually, we also want it to be just sine theta and sine, whoa, that's cubed here, but cubed theta on the right side. So as you think about this here. 3 theta, not something I can work with, but I know addition property. Don't we know something called an addition property here somewhere? All right, so let's see what we begin with here. What I did, and you can go a totally different way as well. This is kind of up to you how you want to do this here. I looked on the right-hand side, and I noticed I can factor out a sine theta out of both of these. That kind of gave me a little bit more room to work with here. So sine theta gets factored out, leaves us with 3 minus 4 sine squared theta. Now that I can start working with right here. So somehow I need to get this right here. So I think that's about as simple as I want my right-hand side. Now let's start working with the left-hand side. The left-hand side, I'm going to do this. I'm going to break it up into theta plus 2 theta. I can work with those. Remember, those 2 should add up to 3 theta. So this is going to be the sum formula for sine. Sum formula for sine. Let's see what happens here. This is sine theta, first angle, cosine second angle, plus cosine first angle, sine second angle. Okay, I got here. Okay, again, end in mind. Thinking about the end in mind. I have theta on the right-hand side. So all these things that have 2 theta I want to get rid of. The only caution I have is, again, this little part right here is cosine 2 theta. Maybe I'll just wait just a little bit on this one, just sort of see how things will work out. Let's see. Okay, coming down. Cosine 2 theta, I'll just wait just a little bit on this one, but cosine theta is here. Sine 2 theta. Sine 2 theta is going to be 2 times sine theta cosine theta. That's what I got there. All right, thinking about this here, you know what I can do? I can factor out a sine theta out of all of this. I have a sine theta in the beginning. I have a sine theta that's being multiplied by 2 in the cosine. So let's take that all out. So I'm going to be left with cosine 2 theta plus, so that one and that one got factored out. this is going to be 2 cosine squared theta. Okay, so think about where I'm headed here. I notice I have a sine squared theta in the front of the right side, and I have a sine squared theta in the front of the left side. That's cool. Now the question is, can I get the stuff in parentheses to look exactly the same? And so now I kind of at least know where I'm headed here. So cosine 2 theta, I'm going to make into formula number 3 plus 2 cosine squared theta. That one is a Pythagorean Theorem identity, right? Cosine squared theta is 1 minus sine squared theta. You know what I forgot here? I forgot to put a bracket to finish this all off like this. There it is. Okay, let's get rid of all the parentheses here. So that's going to be 1 minus 2 sine squared theta. This one's going to be a 2 that's being distributed to each of those pieces. So 2 times 1, 2 times a minus sine squared theta. And I think I know where this is headed now. I think I'm kind of getting this. Yep, that 1 there and that 2 is going to add up to 3. And then the sine squares, both of them have a minus 2 in front of it, will just give you a minus 4. So I had to move on to the next slide because I totally out of room. But we're still working on the left-hand side. I got 1 plus 2 is 3. Minus 2 makes minus 4. And voila, I have my left side that is now exactly the same as my right side. And those wonderful 3 letters in Latin called QED you can put down and you are done. All right, next one, 53 on 5.3. Here's what it starts off as right there. So 1 minus tangent x, 1 plus tangent x on the bottom. Let's see, 1 minus sine 2x over cosine 2x. Okay, let's see how to handle this. And again, you can go a totally different direction than what I did. It's absolutely changeable here. So what I did is I simplified out sine 2x because that has only one formula. There's no other way this can happen except for a 2 sine x cosine x. That's the only way it can happen. On the bottom, again, cosine 2x, that one I'm going to keep like that because I'm not sure which formula I want to use in order to get that the same. Okay, so right side is done. That is about as simple as I want it. Now let's try for their left side. Left side, tangent is going to change into sine over cosine. Boom on top, and then a sine over cosine on the bottom. That's cool there. Still simplifying. I want to get common denominators for the top, the numerator, and put all that together. So that 1 is going to change into a cosine x over cosine x to get a common denominator. So on top, everything else remains the same. On the bottom, same thing happens here. That cosine, or that 1 is going to change into cosine over cosine, plus sine x over cosine x with no change there. And simplifying this together, here it is, just the top. The top itself is going to give us a cosine on the bottom as the denominator. On top, it'll be cosine x minus sine x. On the bottom, it's going to be a cosine x plus sine x over cosine x. Okay, we talked about this in class. If you have a complex fraction and you have the same denominator for the numerator as well as the denominator, you can cross those out. Those will go away. And I'm running out of room. So let's rewrite the simplified form of that right there with the cosines crossed out on my next slide. So it becomes cosine x minus sine x on top, cosine x plus sine x on the bottom. Okay, what I want to do here, let me kind of think what I want to do. I need this to be on the right hand side. That's what I'm trying to go for. Okay, so I got this idea. Let's see if this will work. I'm looking at my denominator, and I'm thinking to myself, you know, I think I can get a cosine 2x out of the bottom. And here's what I'm going to do. I'm going to multiply top and bottom by cosine minus sine x. Okay, so I'm thinking about the bottom here. I'm thinking about the denominator over here. I'm thinking the answer I'm going to get. Because if I multiply cosine x minus sine x with a cosine x plus sine x, the middle terms will cancel. And so what I have is I have a cosine that's being squared minus a sine being squared, and I know that is true, and the formula for that is that. So again, keeping the end in mind, that's what I want to accomplish in my denominator. I'm not sure what's going to happen on top yet. I'm not sure what's going to happen there. How's the top going to be equal to it? So let's go for it here. So what I have is, let me multiply two terms together. So on the bottom, I'm going to multiply cosine x times cosine x squared. The middle terms are going to cancel themselves out because you're going to have a positive sine x cosine x. You're going to minus sine x cosine x. So the only one to multiply is a minus. Sine times sine is sine squared x. And again, according to my formula, this is formula number 1 for double angle formula for cosine. Okay, let's see what's going to happen on top. On top, I got a cosine x times cosine x, cosine squared x. And let's see, FOIL means first one times last one, so that's going to be a minus sine x cosine x. The inside term is going to give me another minus sine x cosine x. And let me extend this out a little further. The last term is going to give me a positive sine squared x. There, that's what it's going to give me. I think I got what I want out of this. Check this out. So on the left side, I know that sine squared x plus cosine squared x is going to give it 1. That's the Pythagorean Theorem right there. So let me write it out. So I have a sine squared x plus cosine squared x on top minus 2 of these. So minus 2 sine x cosine x. On the bottom, I have my double angle formula for cosine. So I'm getting closer. Pythagorean Theorem, sine squared x plus cosine squared x equals to 1. Minus 2 sine x cosine x. No need to change that whatsoever. And I got myself cosine 2x on the bottom. No need to change that either. And voila, I have solved, or at least I've proven this identity. Okay, now you could have taken a slightly different approach than I did, but I think this is kind of probably like the fastest one on this one. All right, QED, and got it done. Our next one is 5.3, number 55. So cotangent 2x, and let me rewrite there it is. There's the rest of it here. On the left, cosine x minus sine x tangent x over secant x sine 2x. All right, and before we begin the problem, we just need to figure out if it is an identity before we start solving it and taking time to solve it here. So what I've done is I've graphed cosine x minus sine x times tangent x, all divided by secant x times sine 2x. That's the blue line right here. And so I'm going to do is using Desmo. I'm going to go back up here and I'm going to click on cotangent 2x. That should be in red. That's the default color here. And if it lines up right on top of the blue line, we have ourselves an identity. Then we have to go prove it. So here it is. 1, 2, 3, go. Yes, that looks so much like an identity right there. Those two lines line up perfectly. So let's go for it here. Let's verify that this is identity. So first things first, for me, let's start with the left-hand side, and I'm going to simplify it down into sines and cosines. At least that'll give me a start on things, and I think that's where I want to keep it, at least for now. And let's see how things play out over here. Okay. On the right-hand side, I am going to change everything into sines and cosines and see what happens here. So cosine x minus sine x, and then tangent is going to be sine over cosine. On the bottom, I have myself a secant, which is 1 over cosine, multiplied with, and I don't want to change that. I don't want to change it because my denominator is already the same. Sine x is here, sine of 2x, sine of 2x. That is right there already. So I guess the rest of it should somehow become cosine 2x. So let's work with that then. So don't change that sine 2x because we have them the same on both sides already. Okay, so let me start working with the numerator on top. Let me get common denominators here. So notice you have a denominator of cosine on the right side because of tangent. So I'm going to put cosine as my denominator. And so I'm multiplying this by cosine over cosine. Minus, and I'm going to get a sine squared x over here over cosine. Okay, I'm going to keep these still separate because I have what I need over here. So then let's put this together here. So common denominators there. We put the fractions together. So therefore I have a cosine squared x minus sine squared x over cosine x. I have a sine 2x over cosine x on the bottom. And hey, this is what we talked about in the last problem here. If the numerator and the denominator both have, or actually I would say if the top and the bottom of a complex fraction have the same denominators, we can cancel the denominators. And I think that is it. Yep, I think I got this here. So do you remember this one is the first formula? This is form 1 for a double angle formula for cosine. And then I have my sine 2x on